Okay guys, this is section 7.4 and it's all about factoring polynomials. And I know for some of you factoring can be kind of tough, but just tough this section out. Make sure you're asking lots of questions if you need it. I'm going to hopefully give you as many types of examples as you might see to make this whole process a little bit easier. So get ready to take some good notes. One thing I want to emphasize is that anytime you're factoring, you always want to look for the greatest common factor first. Remember, greatest common factor is just what all the terms have in common. So basically something you can take out of all of them. And if there is a greatest common factor, anything other than 1, then you always want to take that out first. Because typically in polynomials, if you can take something out, what's left is going to be a lot simpler and easier to work with. And that's going to be what we want to look for. So here, let's take a look at example 1. We've got x cubed minus 7x squared plus 10x. So I want to look at each term and see if there's something they all have in common. Well, every single term has an x in it. So what I'm going to do is I'm going to take an x out. Okay, and what that leaves me with is if I take an x out of an x cubed, I'm left with x squared. If I take an x out of x squared, I'm left with negative 7x. And then if I take the x out of the 10x, I'm left with just a positive 10. And already this makes it a lot easier because now what's in the parentheses is something that's more recognizable for us. It's something that we've factored before. So I'm just going to go ahead and factor. I leave the x out in front, and now I know this is going to be something that has two sets of parentheses because I've got an x squared, so an x and an x. And then my factors of 10 that can get me a 7 are 2 and 5. And now I just have to figure out my signs. I want a negative 7 but a positive 10, so both of these have to be negative because negative 2 and negative 5 add to get negative 7 and multiply to get positive 5. So this answer right here would be your entire factored polynomial. So it's amazing what taking out one greatest common factor can do for your problem to make it a lot simpler. So the same thing is what we're going to do in example 2 here. We've got 3y to the 5th minus 75y cubed. And obviously we've never factored anything with y to the 5th in it before. So what do both have in common? Well, they both have a y, but how many can we take out of both? Well, you always want to look for the smallest amount that you can take out. Well, in this case, they both can take out 3. So I know I'm going to take out a y cubed. And what else do they have in common? Well, I can take out a 3 with both because 3 goes into 3 and 3 goes into 75. So I can take out a 3y squared or y cubed. And what does that leave me with? Well, if I take out the 3, I'm left with just a 1, and I take out y cubed, I'm left with y squared. And if you're not sure if you reduced it right, multiply the two things together and see if you get what you started with. All right? And then when you take out a 3 from negative 75, you're left with negative 25. And I don't have any y's left, so it's just negative 25. And now what's in the parentheses here should be a lot easier to factor. It's a difference of squares because y is squared, and what squared gets you 25? 5. So that means we're going to have y plus 5 and y minus 5. Okay, and we leave that 3y cubed out in front. So this right here is your factored polynomial. So like I said, look for the GCF, take that out first, and then go from there. If you can get the greatest common factor, usually you're going to have a good start to your problem. So now let's look at some special cases. We're going to talk about first the sum and difference of cubes. And I know you had properties from previous sections that we dealt with difference of squares and things like that, and it's very similar types of problems. So our sum of two cubes, this is when we have something cubed plus something cubed. The formula you're going to always use for this is going to be a plus b in one set of parentheses, and then the rest of it's going to be a squared minus a times b, and then plus b squared. Okay? And then the same concept is for the difference of cubes, except the first part is going to be an a minus b, and then a squared plus a times b, and then plus b squared. So they're almost identical formulas except a few signs change, basically. So when you do these problems, my suggestion would be to identify what the a and b are, and then just use this formula every time to fill in your equation, and that should get you through these types of problems much quicker. So let's take a look at a difference of cubes. Or a sum of cubes. Let's say I give you the equation 27x cubed plus 125. Well, we have an x cubed here, but nothing else right away seems cubed. You have to do some mental math and think, okay, does anything here, can it be cubed? And there's no common factors here, so that's not going to help you like it did in the first two. So what I'm going to do is I'm going to write this as something cubed. Well, what cubed gets us 27? Well, in this case it's 3, so I would have 3x all cubed, because x to the third is x cubed and 3 to the third is 27. And then I'm going to do the same thing with the 125. Well, what cubed gets us 125? That's going to be a 5. So I've got 3x cubed and 5 cubed. And now I can identify this as my a and b. So my a is the 3x and my b is the 5. So now I'm just going to go ahead and start filling into my formula. It's a plus sign, so I'm going to use the top equation. So I would get my a, which was 3x, plus the b, which was 5. That's in my first parentheses. And then I fill in the rest. So I'll have 3x squared, okay, and I'm going to use some parentheses, minus 3x times 5, and then plus the b squared, which is 5 squared. And then I'm just going to go ahead and simplify. So I have 3x plus 5 for the first one. Well, what is 3x squared? Well, that gets you 9x squared. Negative 3x times 5 gets us negative 15x, and then 5 squared is 25. And there's your factored polynomial. Now, if you can factor this next part even further, then you want to make sure that you do that, of course, because if you can, then you want to keep going with it. But this is the very first step in factoring a cube. So now let's take a look at our next example. Let's try negative 2d to the 5th plus 250d squared. So this one, you don't even see a cube at all in the equation, but we have a greatest common factor. So what can we take out of both? Well, we can take out a negative 2, and we can take out a d squared. So I'm going to have negative 2d squared out in front. And what does that leave me left over? Well, when I do that, I'm going to get d to the third. And then, because it's a negative, I'm going to change my sign here. And 250 divided by 2, that's 125. And I don't have any d's left. So now I'm looking at an equation with a difference of cubes, because ignoring what's out in front, I have something cubed, and we know 125 can be written as something cubed. So this is why that greatest common factor is so important. So now I'm going to go back to my difference of cubes formula. Well, I know that d cubed can stay as d cubed, and then 125 can be written as 5 cubed. And now I can identify my a and my b. So I'm going to go through my formula, writing into my equation. So let's see if I can write this here. I'm going to leave the negative 2d squared out in front, and I'm going to fill in my a and b. So remember, it's a minus b, so that's going to be d minus 5. And then I'm going to fill in a squared, so that's going to be d squared. And then plus a times b, that's d times 5, which is just 5d. And then plus b squared, which is 5 squared, which is 25. So there would be my final answer. Right, so the process isn't difficult as long as you can identify what your a and b are and make sure you've got your greatest common factor out in front. If you have any questions about difference or sum of cubes, make sure you let me know. Alright, now the last major thing I want to go through is the factoring by grouping, and most of you guys will be able to identify this a lot quicker, because the idea when you're doing factoring by grouping is that you've got 4 terms. So in this case we have 1, 2, 3, 4 different things in our equation. Now just because we have 4 doesn't mean we always can factor by grouping, but most of the time we will be able to. So looking at this example here, if we're going to factor by grouping, basically your first step is to group. So typically you're going to want to group the first 2 together and the second 2 together. So what we're going to do here is I'm going to rewrite this with a bunch of parentheses in here. So we're going to have x cubed plus 7x squared in one set of parentheses. I just wrote the first two. And then I'm going to put a plus sign, and then I'm going to have negative 9x minus 63 altogether. Okay, so now I've got my two sets grouped. Okay, that's the first step. The next step, so second step, is to factor out the greatest common factor if possible. Sometimes it'll have one, sometimes it won't. So let's look at our first equation here in parentheses. Notice that this is an x cubed and we've got an x squared. So what can I take out? An x squared. And what I'm left with is x plus 7. And then I'm going to do the same thing for the other side. Well, what can I take out from both of these? I can take out a negative 9. So negative 9. And what I'm left with is an x and then a plus 7. And what you should notice, and this is very, very important, is that the parentheses, oops, I'll just abbreviate it. So the parentheses should match. Okay, if they don't match, then you might have something wrong, or maybe you grouped the wrong things. Okay, so the x plus 7 and the x plus 7, they match. That's a good thing. So now we're going to go into our third step, which is basically to rewrite it as two sets of factored items. So what I'm going to do is I'm going to use the outside ones, so my ones that I just squiggled under, so my x squared and my minus 9, and I'm going to write that in a parenthesis, and then the x plus 7s that match, I'm going to write in one set of parentheses. And now this is much easier. So the last step basically is to simplify if possible. Okay. And we know that x squared minus 9 can be reduced because it's difference of squares. So this becomes x plus 3 and x minus 3, and the x plus 7 stays where it is. So x plus 7. So there is our factor by grouping. All right, so most of you are going to like this, like I said, because you can find greatest common factor, group some stuff together, and then reduce it. It's going to make it a lot easier rather than trying to use fancy formulas and finding odd numbers and decimals that work. This is what you want to look for. All right, so I'm going to go through one more example, then I'm going to have you try a few on your own. So here we've got 3m squared or cubed minus m squared plus 9m minus 3. So remember, first step is to group. So we have our first two together and our second two together. Oops, minus 3. And the second step is to find those GCFs. So in the first one we can take out an m squared, and we're left with 3m minus 1. And then I can also take out a 3 from the other one, and that leaves me 3m minus 1 as well. And then third step is to rewrite it. So we have our ones on the outside. So that's m squared plus 3, and then the ones that match, okay, which remember we want them to match. And this one you can't go any farther because this is not a difference of squares, even though it looks like it might be. It has a plus sign, so we can't reduce it. So this would be our final answer. Not too bad, hopefully. Like I said, got to just get some practice identifying them, but grouping is identified by the 4. Now, I want you to go ahead and pause the video and try this one on your own. Notice that there's 4 terms, so this is going to be another factor by grouping, and then check your answer. Alright, so this is the steps that I came up with for the factoring by grouping. Obviously, step 1 was your factoring by the grouping part, where you group the first two and the last two. And then step 2 was where we find our greatest common factor. So really, in the first two sets, all I found was a 25s squared, and that left me with s minus 4. So almost everything was factored out. Now, the second one might have been a little trickier because it looks like there's nothing in common, but you want an s minus 4 because remember, what's in parentheses has to match. So I just took out a negative 1, and what that did was it changed my signs of my s and of my 4. So now my parentheses match. So now I can go ahead and rewrite my equation in step 3. So I had 25s squared minus 1. That was from the outsides. Okay. And then I had my s minus 4s that matched, and I rewrote that as 1. And then the last part is to simplify it. And remember, 25s squared, it's a perfect square. So we have 5s plus 1 and 5s minus 1. and then the s minus 4. So this right here is my final answer. If you would have stopped right here, you were almost done, okay, but not quite because you have a difference of squares. So really make sure you're practicing identifying those difference of squares. Okay, now these last couple ones, these are just extra practice problems that I want you to look at if you are given an opportunity to just have any method that you want. You always want to try to identify some key things that are going to make it a lot easier for you to look for. Remember, greatest common factor is the first one. So here, we're going to look for greatest common factors. Well, unfortunately, this doesn't have a greatest common factor, but what we can notice is that these are all perfect squares. Okay, 16 can be written as a perfect square, 4 can be written as a perfect square, and so can 625. So what we're going to do is try to figure out what perfect squares we're going to use in order to get our answer. So we know that 16 can be written as a 4 and a 4. Okay. And then g to the fourth can be split so that there's two g's, so g squared and g squared. And then the last part is figuring out, well, what's the square root of 625? Well, that's 25. So we'd have 25 and 25. And because it's a difference of squares, we have a plus and a minus. And then you have to keep going. If you see any other difference of squares, you have to reduce it as well. Remember, difference means subtraction. So notice right here, we have squares again. So I'm going to split this one more time. 4 can be reduced to 2 and 2. And g squared can be reduced to g and g. And then what's the square root of 25? It's 5. So we split that one more time with another plus and minus. And this one on the right doesn't change because it's a plus sign, so we have to leave that as is. So 4g squared plus 25. So this right here is our final answer if we've reduced it all down. So there was no greatest common factor. It's all about just difference of squares. Right. The next one, it definitely has a group of greatest common factors. Notice that all of these can have a 4 taken out of it, and we can also take out a t squared. So I'm going to go ahead and do that. So I'm going to take out a 4t squared, and what I'm left with is t to the fourth minus 5t squared, and then plus 6. So now I can go ahead and try to factor if possible. And if this is all you can do, then you would obviously stop here. The one thing that you want to look for is if you can factor this in parentheses. Okay. I would like you to go ahead and try these last two on your own. The key I want to make sure you catch on this one is that you need to move this 14x cubed over so that everything is set equal to 0. Okay, you don't want to have variables on two sides of an equation. So subtract 14x over, x cubed over, then try to do your greatest common factor. So press pause, try those on your own, and then check your answers. Alright, so I went ahead and wrote the first step in these factoring problems. Both of them have a greatest common factor, which is really nice because it simplifies your problem significantly. So in the one on the left, I was able to take out a 4 and an x, and that left me with x to the fourth minus 10x squared plus 9. Now you can't stop here because this right here in the parentheses can be factored further because you can split the x to the fourth and factors of 9 can get you 10. So what we're going to do is split this into two parentheses just like before. So instead of just having x and x because there's 4 of them, we're going to split it in half, x squared and x squared. And then what are the factors of 9 that can get you 10? Well, that's going to be our 9 and our 1. So we'll have a 9 here and a 1 here. And we want them to both be negative because that'll get us negative 10. And then the last thing you have to look for is difference of squares. Well, 9 is a perfect square and so is 1. So, and these are both subtraction. So we can break both of these down even further. Okay, so I'm going to break this into these two. So x and x, and then 3 and 3. Like I said, difference of squares is going to be your best friend in terms of factoring if you can identify it. And then this very last one here, I'm going to break down into two more. We'd have x and 1 and x and 1 with a plus and a minus. So this one factors significantly because we've got so many pairs of difference of squares. So this would be your final answer. Okay, and then the one over here on the right, I took out a 2x once I moved the 14x cubed over. And notice I put the x cubed in order from highest exponent down to least. That makes it a lot easier. And now I can go ahead and factor what's on my parentheses here. So I leave the 2x, and same thing is on the left. I have my two parentheses, and I have x squared and x squared. And I want factors of 12 that can get me a 7. Well, 1 and 12 can't, 2 and 6 can't, but 3 and 4 can. So I'm going to have a 3, and I'm going to have a 4, and I want both of them to be negative. Now, this is where you got to pay attention. You're looking for difference of squares, and the key is that they both have to be a square. But is 3 a perfect square? Well, it's not, so this one can't reduce, so I keep that the same. But 4 is a perfect square, so this one can be split into x and 2 and x and 2, and then with a plus and a minus. So really pay attention for those perfect squares. You've got to know them. I know you learned them in 8th grade, and we talked about them before in geometry, and even last semester. So those are your two answers. So if you got stuck on a step and you still need some extra help, please ask before you move on to the next section, or ask when you go through your practice problems. Thanks for listening.